Hello and welcome to this ninth algorithm selection and development lecture in this course Master in Artificial Intelligence. So in this particular lecture we will talk about another hyperparameter that is number of hidden layers in a neural network to help you select appropriate algorithm to become a successful artificial intelligence engineer. So, what is a number of hidden layers in neural network? So, as we saw, hyperparameters are parameters that are set prior to model training and they control the learning process. And one of them is number of hidden layers in a neural network, and mostly it is very commonly used in deep learning algorithms. So the number of hidden layers in a neural network refers to the layers between the input layer and output layer as you see here. So as you see x1, x2, xn, there are the layer 1 input data and then there is a layer 4 of output hypothesis. In between there are layer 2, layer 3 that is hidden, and that's what, so in this we are showing you two layers. So it refers to number of layers between the input and output layer where the data is processed through a series of transformation. The X data is transformed. In a neural network, these hidden layers consist of nodes, also called neurons, as you see here. Each of these layer has certain number of neurons that perform computations on the input data. The architecture of the neural network typically includes multiple hidden layers, each containing a variable number of these nodes. The number of hidden layers and number of nodes in each layers are the hyperparameters that can be adjusted during the design and training of the neural network, right? So, what determines the choice of number of hidden layers and nodes in each layer? So the factors that determine this first is the complexity of the problem. More complex problems may require deeper architectures with more hidden layers to capture intricate patterns in the data. So the complexity of the problem is the first factor. Second is the size and complexity of the data set. Larger and more complex data sets may benefit from deeper architectures with more hidden layers to learn meaningful representations. So size and complexity of the data is the second parameter. The third is the computational resources. Deeper architectures with more hidden layers require more computational resources in terms of memory, processing power for training and inference, right? So computational resources is the third one. The fourth one is overfitting versus underfitting. Adding more hidden layers can increase the capacity of the model, potentially reducing underfitting. However, it may also increase the risk of overfitting, especially if the data set is small or noisy. And lastly, the training performance. Deeper architecture with more hidden layers may require more training times, more careful hyperparameter tuning to achieve good performance. So that's what these are the factors that determine the number of hidden layers and nodes in a neural network. So in practice, the optimal number of hidden layers and nodes is often determined through experimentation. There is no formula as yet. And the tuning, experimentation and tuning is what determines it using techniques like cross-validation and grid search. We have looked at cross-validation, grid search we will look at as we go forward. Now there is no one size fits all answer. So there is no formula directly that you can plug and play. And the architecture of neural network should be tailored to the specific problem and data set at hand, right? So what do we do next? We will look at the third majority common hyperparameter used, the regularization strength, in the next set of lectures as we go forward. So thank you so much for watching this ninth algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please do feel free to download the PDF file and take a look at anything that you need to specifically of interest to you.